Hello everyone, welcome to day 4th of September Leetcode challenge, and today's question is partition labels. As usual, let's go through the question together. Given a string S of lowercase English characters, so this is important that the string only contains lowercase English characters. We want to partition this string into as many parts as possible so that each letter appears in at most one part. So we want to partition a string and each part should contain at most one character. So one single character should not be part of two different substrings. Return the list of integers representing the size of these parts. Remember, we need to return the size, not the index where the partition has to happen. So we'll keep this as a note while designing our algorithm. Let's go through this example. So here you got A, and you want to make the first substring till the last point where you found A. So this becomes one substring. The other becomes something like from D to from E to E. So from D to E, it becomes the other part because we want E to be intact altogether. E to be intact altogether, and the last part is H I J K L I J. So this becomes the last part of your string. Let's just discuss about the algorithm that will help us solve this problem. So moving on to the slideshow that I have created. A partitions label day4. So let me just reduce the problem statement to a very simple example, and let's try to devise some algorithm. The solution or the approach that we are going to follow is a two-pointer approach. Two-pointer approach is very typically, as in interviews, is a very efficient way to understand the thought process of the interviewee. The interviews are very keen discussing two-pointer solutions, so because it tells how a person thinks. So on the similar lines, let's just understand how two pointer will help us devise the answer. So let me just take a pen. So here I have taken a very small example, A, B, C, D, A, E, F. So the first step to solve this question is you'll store the last index where each character occurs in the string. This is the array that signifies that value. For example, A occurs at the last index of 4, this point. B occurs at 1, C occurs at 2, E occurs at 5, F occurs at 6. So you stored it in an array somewhere. Now what you will do is you will start iterating and store the last pointer, the last index up to which you need to iterate. What it means is you have a variable which stores a last index up to which you need to search in your subarray. So you witnessed A at first, and you find its last position is 4, and your last pointer becomes 4. So last pointer is 4, and this value, and you come to B, and B lies within. You search for the last frequency of 4, the last frequency of B, which is 1. It's still within the range. It's good. You moved ahead in the array, moved ahead in the string. Then comes C. You search for the last frequency of C. It's 2. It is within your last pointer, which is 4. And now comes D. Its last frequency is 3. It is still within it. All good. Move ahead. And as soon as you find that the last max frequency is equal to your current iterating value, you add it to your array. So as soon as this becomes equal, you found one partition. So you partition it here. Move ahead. Then you again see F. You incremented your last pointer as you move. You have to move to the next value, and now last pointer becomes F, and it is equal. You make another partition, and similarly here as well, you made another partition at 6. So your indices will store three values, 5, 6, 7. What you can do is you can iterate through the indices, divide the previous value, and get your answer. The other thing that you can do is you can store another start variable which will reset, which will actually calculate the length rather than the index, and you can use another variable known as a start where which will keep track of the previous length that has been witnessed, and you can update the length while iterating through the array. So this is pretty simple. Let me just explain what all steps are included. Store the last indexes of all the characters. Update the last pointer as you iterate over this string. You have to make a comparison max of the last index of the current character versus the last pointer that is storing your previous value. So max of that value, that signifies you need to move the last pointer forward or not. So as soon as you're iterating to the pointer, your iterating pointer becomes equal to the last pointer, you stored it in the result. You can keep a start pointer as well to find the difference and update your result accordingly. Otherwise, you can, if you are storing the last pointers, you can iterate through your result array and subtract the previous value from the current value to find the length. Let's code it up now. Defining the last index array that will store the index where each character occurs at the last at the last position in this string. So defining the new array of size 26, since we only have lowercase characters, s dot length I plus plus char c equals to s dot char at I integer index equals to c minus a. So last index of the index, the current character, equals to I. So I'll explain one more thing. How is it storing the last character? For example, A, B, C, A. You got A. So got set to 0 first, B got set to 1, C got set to 2, and you received A again. So it will automatically store up, the value will automatically get updated because it's for the same character A, and the last value will get stored. So A will store 1 now. The 0th index will store 1 now. Now let's iterate through the string again, finding the solution s dot length s plus plus. Before that, let me just define my integer array that will store the answer result. New array list, and I need to define another pointer that is last index that will store the width up to which I need to search and update it to the max value of the current last index versus the previous value that was stored. So initialize it to -1. Integer current last index equals to last index array. I'll search in the last index array s dot char at I minus a, and my last index equals to math dot max last index versus current index. And if my last index equals to I got one of my partition, add it to the partition, last index or I, either of them. Yeah, one more thing that I need to highlight here is the indexes start from 0 till the length L minus 1, while we need to store uh, the actual length. So I'll be adding 1 to it and return ANS. So I'm yet to add the support for the length. This will store the indexes where the partition has to happen. I want to show you first, and then I'll add the support for the actual length. So you stored the indexes where the partitions are actually happening. Now to incorporate the length part, I'll initialize another variable named as start, and I'll set start to last index plus 1, and I'll subtract start from it. Yeah, it passed because now I'm storing the previous value where the last partition happened, and while storing my result, I'm actually storing the difference rather than the actual pointer, the actual partition index. Let me just submit it. Accepted. Let me just walk you through the algorithm once more. So you created an array of size 26 which will store the last index position in the array for each character. So this array is doing that. The last index gets updated to the I value as soon as you see a previous character or a new character. You created your result array. You initialize your last index to -1. That will hold the width of where the partition has to happen, or till what point you need to iterate. You calculated the last of the last index of the current element using your last index array, index last array, and last index equals to the maximum of those two values. So this is at the actual width up to which you need to search, and whenever I becomes equals to the last index, you found a position to break, and you added it to your result array. You have another pointer to store the previous value of where the partition happened, so that you can store the difference rather than the actual position of partition. That's it. Hope you like the solution, and the time complexity of this solution would be order of n. You're iterating over the length once, and again here so twice. We are iterating over the length twice, so it's order of n. And the space complexity of constant space, because this is a constant space array of size 20.